Assalamu alaikum. Today we are going to do October-November 2023, paper 4-2. The code is 9709. In our first question, a block of mass 15 kg slides down a line of greater slope of an inclined plane. The top of the plane is at a vertical height of 1.6 meter above the level of the bottom of the plane. The speed of the block at the top of the plane is 2 meters per second and the speed of the block at the bottom of the plane is 4 meters per second. Find the work done against the resistance to motion of the block. To solve this, we have to make a diagram. Suppose this is a slope and at the top the block is here and it's going to slide down. So its initial velocity is 2 meters per second, and when it reaches at the bottom, its velocity is 4 meters per second. Height is given as 1.6 meter. So we will use the work energy principle, which says total work done equals increase in mechanical energy so our total work done can be calculated in the way that if I write work done to increase speed minus work done against resistance. And this is our total work done. This should be equals to increase in mechanical energy, and that comprises of increase in kinetic energy plus increase in potential energy. And our increase in kinetic energy further comprises of final kinetic energy minus initial kinetic energy and the same will happen with potential energy, and that would be final potential energy minus initial potential energy. Now, for the work done to increase speed, I'm going to write 0 here because due to slope there is no work done. So 0 in under this minus work done against resistance. Work done against resistance. That is equal to final kinetic energy. The formula is half mv square. So half m is 15 and v is 4 minus initial initial kinetic energy, again half mv square would be used. So half, and m is 15 and v is 2, plus, now final potential energy. The formula for potential energy is mgh. So m is 15, g is 10, and height is 0. When the block comes down, the height becomes 0 there, minus initial potential energy, again mgh, m is 15, g is 10, and height is given 1.6. So minus work done against resistance equals, if you saw all of this, the kinetic energy portion, you will get 90 plus, and when you solve the potential energy side, you get minus 240. So minus work done against resistance equals minus 150. So minus will cancel each other out. So your work done against resistance would be equals to 150 joules. This is your answer for this question. Question number 2. The diagram shows a smooth ring R of mass mkg threaded on a light inextensible string. A horizontal force of magnitude 2 Newton acts on R. The ends of the string are attached to fixed points A and B. On a vertical wall, the part AR of the string makes an angle of 30 degree with the vertical. The part BR makes an angle of 40 degree with the vertical, and the string is taut. The ring is in equilibrium. Find the tension in the string and find the value of M. So if I start making diagram on this, this is my tension in this way, tension here in this way, so 30 comes here and 40 comes here due to alternate angles. So upward it would be T cos 30. This is 90 here, and downward it would be T cos 40 plus mg, the weight. So if we start solving the forces horizontally, I can say that T sine 30 plus T sine 40 would be equals to 2, that is 2 Newton. And solving for T, we will get 1.143 T is equal to 2. So from here your T equals 1.75 Newton. And when you start solving the forces vertically, so you have T cos 30 equals T cos 40 plus mg. If you see the diagram, the vertical force is T cos 30 and the downward is, there are two forces, T cos 40 plus the mass mg. So simplifying this part, T cos 30 minus T cos 40 equals mg. Make m the subject, you get T cos 30 minus T cos 40 divided by g, and your g is 10. So you put all the values in it and you get the mass, which is 0.015, sorry, 175. Now your question number 3. A block of mass 10 kg is at rest on a rough plane inclined at an angle of 30 degrees to the horizontal. A force of 120 Newton is applied to the block at an angle of 20 degrees above a line of greater slope. There is a force resisting the motion of the block and 200 joules of work is done against this force when the block has moved a distance of 5 meters up the plane from rest. Find the speed of the block when it has moved a distance of 5 meters up the plane from rest. So let's solve the force, make the diagram of forces here. Here is our normal, which we write as R, and here is the direction opposite to it. So this is our weight, which is 10g, and suppose this is the distance it moves, the block has moved 5 meters, and from here if I make a right angle triangle to get the height, this would be my height, so this is my 30 degree angle. Let me write it with different colors so that it should be prominent. So my sine 30 is equal to opposite over hypotenuse, which is 5 meters, and my opposite is my height, so my height is 5 sine 30, which is equal to 2.5 meters. meters. So in the opposite direction I can say this is my resisting force, so I write it Fr. So let's try to solve it. So we are going to use work energy principle method. So, and that is work done to move the block minus work done against resistance, and that is equal to final kinetic energy minus initial kinetic energy plus final potential energy minus initial potential energy. So my work done to move is, because the block has to go up, so I can say that it is along the slope, so it, and my angle is 20 degree, so I will write force is 120 Newton applied, so I can write 120 cos of 20 degrees into the distance, which is 5 meters, minus work done against the resistance, that is given 200 joules. So this is equal to final kinetic energy, half mv square. So half mass is 10 and v square we don't know, minus initial kinetic energy, again half mv square. Half mass is 10 and v would be definitely 0. So plus final potential energy mgh. So mass is 10, g is 10, and height is, we just found out, 2.5 meters, minus initial potential energy mgh again. So mass is 10, g is 10, and initial potential energy, so our initial potential energy, our height is, at that point our height is 0. So this part would be not considered because it becomes 0, and this part will become 0. So our further simplification is 363.82 equals 5v square plus 250. From here we can find our v. So make 5v square subject, so it becomes 363.82 minus 250, and our v square would be 113.817 divided by 5, and that is 22.76. And by taking square root on both sides, our v would be square root of 22.76, and finally our velocity would be 4.77 meter per second. This would be our answer for this question. Okay, question number 4. A particle P of mass 0.2 kg lies at rest on a rough horizontal plane. A horizontal force of 1.2 Newton is applied to P. In part A, given that P is in limiting equilibrium, find the coefficient of friction between P and the plane. So suppose our plane is horizontal and our particle is here. So this is our normal R, this is our weight 0.2 g, and in this direction our force is 1.2 Newton, and the opposite is our frictional force. So I write it like capital F and small f as our frictional force. So my R would be equals to 0.2, G is 10, and because it is horizontal, so no sine and cos, so our R is equals to 2. Now 1.2 would be equals to frictional force, and frictional force is our mu R, so I can write 1.2 equals mu R, and 1.2 equals mu time R is over 2. So from here our mu would be equals to 0.5. This is our coefficient of friction. In B part, he says, given instead that the coefficient of friction between P and the plane is 0.3, find the distance traveled by P in the third second of its motion. So to find the distance traveled in the third second, find acceleration first. So for that, we have to use F equals ma. So my F is 1.2 minus mu r, which is my frictional force, and my mass is 0.2, and my A is unknown. So 1.2 minus mu has given to us 0.3, and our R is 2. So this is equal to 0.2A. From here, if we make A the subject, our A would be 3 meter per second square. Okay, for third second, wait. I'm going to use, let me write it here for third second. I'm going to use the formula S is equal to ut plus half at square. So my S is going to be sorted out. My initial velocity would be 0. My time is 3 because I'm using the third second, plus half. A is my 3, which I just found out, and my T is again 3 square. So when we solve it, I get the value 13.5 meter. In my third second, my distance is this. Okay, now work for the second second. Again, I'm going to use S is equal to ut plus half at square. So u is 0 again, T is my 2, plus half, and my A is 3, and my T is again 2. This is square, so when you solve it, you get 6 meters. So distance traveled in the third second would be 13.5 minus 6. So 7.5 meters. That is your answer. Question number 5. Question number 5 says a particle A of mass 0.5 kg is projected vertically upward from horizontal ground with speed 25 meter per second. In part A, find the speed of A when it reaches a height of 20 meter above the ground. So let me make a small diagram. Suppose this is our particle projected upward, and height is suppose 20 meters here. So our what is velocity, and mass is given 0.5 kg, and initial velocity is also given, which is 25 meter per second. So simply use v square equals u square plus 2as. So v square equals 25 initial velocity square plus 2 into a is actually over negative 10 because it's going upward, and my s is given 20. So simplify this, you will get your velocity 15 meter per second. Okay, then for part B, he says when A reaches a height of 20 meter, it collides with a particle B of mass 0.3 kg, which is moving downward in the same vertical line as A with speed 32.5 meter per second. In the collision between the two particles, B is brought to instantaneous rest. Show that the velocity of A immediately after the collision is 4.5 meter per second downwards. So suppose here is your B going downward, and its initial velocity is given 32.5 meter per second, and say when it reaches here that this is your B, and it collides with the particle A which is coming up. So let me show it with different color. This is a particle A, and its velocity is 15 meter per second, and this came from part A, and this distance, this is our A was here when it was projected upward from the ground, and this distance was also given to us, and that was 20 meters. So now its initial velocity was 25 meter per second. So let me solve it. It's upward linear momentum. So MA VA plus MB UB equals MA V prime A. V prime means is the velocity after collision, okay? So plus MB VB. So MA is 0.5, VA is 15 plus MB is 0.3, and UB is, I'm writing minus 32.5. I'm taking minus because it's coming downwards, and MA again 0.5 times V prime A. As I told you, V prime is the velocity after collision. So plus, so MB is 0.3 times velocity of B is 0. So that would be gone, this part. So you get 7.5 minus 9.75 equals 0.5 V prime A, and your V prime A is negative 4.5 meter per second, and negative sign shows that it is moving downward because when it hits particle B, it starts coming down. So you can write the velocity of A after collision is 4.5 meter per second. That's it for this part. For part C, find the time interval between A and B reaching the ground. You should assume that it does not bounce when it reaches the ground. Okay, suppose this is our A and its distance is given to us from the ground, which was 20 meters, and you can write for time of A, and here you can write time of B downwards. So S is equal to ut plus half gt square. So S was 20 and initial velocity was 4.5, which we just found out in this part, and t is going to be calculated plus half g is over 10 and t square. So when you simplify this, you multiply the whole equation by 2, so you will get 40 equals 90 plus 10t square, and further simplification would show you 10 square plus 90 minus 40 is equal to 0. Factorize this, you will get the factors 5t minus 8 and 2t plus 5 equals 0. So 1 your t is 8 over 5 and other your t equals negative 5 by 2. So your answer for this would be t equals 8 over 5, or in decimal you can say 1.65. Okay, now work for particle B. Use the formula S is equal to ut plus half gt square. So u is again 20 and initial velocity would be 0, time is unknown, so g is your 10 and t square, so your 20 equals 5t square and t is equal to 2 seconds. Time interval between two particles two minus 1.6 0.4 seconds. That's it for this question. Now question number 6. A railway engine of mass 120,000 kg is towing a coach of mass 60,000 kg up a straight track inclined at an angle of alpha to the horizontal where sin alpha is 0.02. There is a light rigid coupling parallel to the track connecting the engine and coach. The driving force produced by the engine is 125,000 Newton and there are constant resistances to motion of 22,000 Newton on the engine and 13,000 Newton on the coach. Find the acceleration of engine and find the tension in the coupling. Okay, so let's make a diagram. Suppose this is our slope and our angle alpha is here. Say this is a engine and this is a coach. So our driving force, I write a dF, is given 125,000, and if I draw this, my alpha is here, and my weight is 120,000 G. So tension this way, tension this way. My acceleration goes up. Here is our coach, and my FC, which is my resistance to coach, and my FV is in this direction. This is resistance to engine. Alright, now I'm going to consider the whole system. This is, let me write engine here. Whole system means engine plus coach. So to find acceleration, F equals ma. My F is actually, now look, 125,000 minus 1200, 12,000 wait, it is 120,000 G sine of alpha minus 22,000 minus 60,000 G actually this is the weight, 60,000 G, 60,000 G sine of alpha minus 13,000, that is the resistance of coach. Okay, this would be equals to mass, because I'm considering the whole system, so I'm going to write the mass of both engine plus coach, which is 60,000 plus 120,000, and this is my A. Okay, so 125,000 minus 120,000 times G is my 10, sine alpha is given as 0.02 minus 22,000 minus 60,000 sine G is my 10, sine alpha is 0.02 minus 13,000, and this is equal to 180,000 A. Simplify whole of this, you get 54,000 equals 180,000 A, and from here your A is 0.3 meter per second square. Okay, to find tension, consider either engine or coach. So I'm going to pick engine. Consider engine. So I'm going to write F equals ma again. My force is 125,000 minus 120,000 G sine of alpha minus T minus 22,000, and this is equal to, now take the mass of engine only, which is 120,000, and your acceleration is 0.3. So now simplify this. 125,000 minus 120,000 times 10 times 0.02 minus T minus 22,000. This is equal to 36,000. And from here, if you isolate T, you will find out its value as 43,000 Newton. That's it for this part. At an instant, when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle of beta to the horizontal. The power produced by the engine is now 4,500,000 watt, and as a result, the engine maintains a constant speed. Assuming that the resistance forces remains unchanged, find the value of beta. Okay. So let me quickly draw this diagram again. Suppose this is my beta here. Engine, coach, tensions, D, FC, there is FE, resistance to engine. This is 120,000 G, this is 60,000 G. Now initial velocity is 30 meters per second. Your A is 0 because it attains the constant speed. Your acceleration is 0 there, so your formula for power equals distance into velocity. So power is your 4,500,000 equals your distance is unknown and your velocity is 30. So your D is 150,000 Newton. Now consider the whole system again. You write F equals ma. So 150,000 minus 120,000 G sine of beta minus 22,000 minus 60,000 G sine of beta minus 13,000, that is equal to mass is your 180,000. Because I took the whole system, so we have to add engine and coach weight together, and your acceleration is 0, so this part is gone. So $150,000 minus 120,000 G is your 10 sine beta minus 22,000 minus 60,000 into 10 into sine of beta minus 13,000, 130,000 is equal to 0. Now further if we simplify this, 150,000 minus 22,000 minus 13,000, and that would be equals to 120,000 sine beta plus 600,000 sine beta this is one more zero here because of 10. So this is 600,000 sine of beta. So we will get 115,000 equals 1800,000 sine of beta. So your beta is 3.7 degrees. This is your answer. Question number 7. A particle x travels in a straight line. The velocity of x at the time t second after leaving a fixed point O is denoted by v meter per second, where v is this. The acceleration of x is 0 at t is equal to p and t is equal to q, where p is less than q. Find the value of p and the value of q. So as we know, acceleration if we take a derivative of velocity dv over dt, so that would be our acceleration. So our v is given minus 0.1 t cube plus 1.8 t square minus 60 plus 5.6. So I take the derivative. So dv over dt. So this is minus, when 3 comes down and multiply by 0.1, so you get minus 0.3 t square, because we bring down the power and we subtract 1 from the power, plus bring down 2 and it multiplies with 1.8, so you get 3.6, and 1 minus from 2 you get 1, minus the derivative of 66, and the derivative of 5.6 is 0. So you get the acceleration equation, which is minus 0.3 t square plus 3.6 t minus 6. You multiply by 10 and then divide it by 3, and you put a equals 0, you will get t square minus 12t plus 20. I repeat, you multiply this acceleration equation by 10 first, and then you divide that the whole equation by 3, you will get t square minus 12t plus 20. So factorize it, you will get t minus 10 and t minus 2 equals 0. So t equals 10 and t equals 2. So he said p is less than q, so your p is 2 and q is your 10. This is your answer. Second part says it is given that the velocity of x is 0 at t equals 14. Find the velocities of x at t is equal to p and at t equals q, and hence sketch the velocity time graph for the motion of x for 0 to 15. Okay, when t is equal to 2, you put this value of 2 in the velocity equation. 2 cube plus 1.82 square minus 6 times 2 plus 5.6. This gives you 0. And when t is equal to 10, v equals, you put 10 in t in the velocity equation, and this gives you 25.6. We know that velocity at t equals 14 is 0. At t is equal to 14, v is equal to 0, which is given in the question. Now calculate the velocity when t is equal to 15. So v equal minus 0.1, 15 cube plus 1.8, 15 square minus 6 into 15 plus 5.6, and this gives you minus 16.9. And now in the last, we should also find out when t is equal to 0. So what is our velocity? Minus 0.1, 0 cube plus 1.8, 0 square minus 6 times 0 plus 5.6. This gives us 5.6. Now we have all our values. So let's sketch the graph. Here is our velocity, here is our time. Suppose if I write 5, 10, 15, 20, 25, 30. Here is 0, 2, 4, 6, 8, 10, 12, 14, 16, and here is a minus 5, minus 10, minus 15, and minus 20. So our points would be at whenever t was 0, our velocity was 5.6. Somewhere here, when our t was 2, our velocity was 0. So here is our point. When our t is 10, our velocity was 25.6. So somewhere here, and when our t is 14, our velocity is 0, and when our t is 15, suppose 15 is here, so our velocity is minus 16.9, which is near 20, a little above 20, suppose here. So now you can join all these points. So this would be our sketch. Find the total distance traveled by x between t0 and t15. So for this, you have to integrate the distance and 0 to 14 minus 0.1 t cube plus 1.8 t square minus 60 plus 5.6 dt plus second portion of integration will be from 14 to 15. So same equation, minus 0.1 t cube plus 1.8 t square minus 60 plus 5.6 dt. Now first let me integrate. So minus 0.1 t power 4 over 4 plus 1.8 t3 over 3 minus 62 over 2 plus 5.6 t, and the limits are 0 to 14 plus minus 0.1 t 4 over 4 plus 1.8 t 3 over 3 minus 6 t square over 2 plus 5.6 t, and the limits are 14 to 15. Now for the first portion, I have to write upper limit minus lower limit. So upper limit is minus 0.1 14 power 4 over 4 plus 1.8 14 power 3 over 3 minus 6 into 14 power 2 over 2 plus 5.6 times 14. This is upper limit minus now lower limit. So minus 0.1 0 power 4. So everything is 4. 0. So this would be gone. Plus now for the second portion, whose limit is from 14 to 15, upper limit minus lower limit, minus 0.1 15 power 4 over 4 plus 1.8 15 power 3 over 3 minus 6 15 power 2 over 2 plus 5.6 times 15, upper limit minus now lower limit, and that would be minus 0.1 times 14 power 4 over 4 plus 1.8 14 power 3 over 3 minus 6 into 14 square over 2 plus 5.6 times 14. you solve everything, you will get 17.6.4 plus, so you will get negative sign in the last portion, minus 8.025. So this from 14 to 15, actually this part is here. We are calculating area of this portion, so this is below x-axis, so definitely the answer would be in negative, so ignore the negative sign. So you take 176.4 plus 8.025 and you get 184 meters the distance. So that's it. Our paper has been finished. This is 3. This is my cell number. You can contact me on my WhatsApp. Thank you very much.